Hi friends, today we're talking about angle, side, angle, and angle, angle, side, proving triangles are congruent via angle, side, angle, and angle, angle, side. So what is angle, side, angle? This one, when we have two triangles and we've proven that one angle is congruent to the other, and then another angle is congruent to the other, and the side in between them is also congruent, that is angle, side, angle. Angle, angle, side is where we have two congruent angles similar to the last one, but a side that is not included in the middle of those angles. So once we have that, we can prove that these triangles are congruent. So let's do some proofs so you can see how this works. All right, for our first proof here, we are given that JK is parallel to LM, and JL is parallel to KM. Okay, if you haven't seen this before, here's my cheat sheet. You may want to pause and write these down. We always start with our givens, and we do our definitions, our obvious but not givens, and then our SSS, SAS, side, 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 angle, side, all that good stuff. So the first thing we're going to do is our givens. So we have our statements and our reasons. Usually I write these guys down beforehand. I don't know why I didn't. Sorry about that, folks. So we've got number one. We have JK is parallel to LM, and JL is parallel to KM. These are our givens. Now, the next one that we have are our definitions, and I don't see any definitions here. Usually that's like bisector and midpoint. I don't see any definitions here, so we're going to move on to what I call our obvious but not givens. Things like angle relationships with parallel lines, reflexive property, vertical angles, things like that. Now, I do know that because these are parallel, we should go ahead and mark those. So let me grab these guys and say, okay, because JK is parallel to LM, and then this guy is parallel to this. Now, that doesn't mean they're congruent. The arrow means just that they're parallel. Okay, so part of our obvious but not givens are parallel line relationships, or parallel lines angle relationships. So what that means here is because these guys are parallel, this angle and this angle are congruent. This angle and this angle are congruent because these are alternate interior angles, and alternate interior angles are congruent. So what I can say is angle JKL is congruent to MLK, and JLK is congruent to angle MKL, because alternate interior angles, if two lines are cut by a transversal, the alternate interior angles of those lines, or two parallel lines, are cut by a transversal, then the alternate interior angles, I don't know why I can't spell today, interior, just kidding, that's every day, angles are congruent. I'm not sure if your teacher wants you to write the full definition or if that's going to be sufficient. If you need the full definition, you'll have to go back and look that up. So number three, so that's a part of our obvious but not givens, right? We also have another obvious but not given here, and that is our reflexive property. If I were to separate these two triangles out, KL would be congruent to LK. So for number three, we've got KL is congruent to LK. And notice I had to use those in a different order, and that's because the way the triangle, when we go to do our congruency statement here, you'll see that we go like from the 1 dash of the angle to the 2 dash on the bottom triangle, and then on the top triangle we go from the 1 dash to the 2 dash. So we need to make sure that we're doing that correctly. All right, so those guys are congruent because reflexive property of congruence, or reflexive property. Okay, so now if I were to cover up one of these triangles, or if I were to draw them out separately, you see that I would have an angle, a side, and an angle. So the side is included in between those two angles. So what I can say now is triangle JKL is congruent to triangle MLK because of angle, side, angle. So again, going through our little congruency triangle congruency proof checklist. This again isn't for every proof, but it is a good way to start if you're not sure where you need to begin. Okay, so let's try another one of these. Okay, so for this guy, we've got, go ahead and take a moment, pause this, and write this down. All right, so we are given that AD is parallel to CE. So AD and CE are parallel. BD is parallel to, or is congruent to BC. BD is congruent to BC. Okay, we need to prove that these two triangles are congruent. Well, what we can do is say angle DAB is congruent. So for number 2, so we've obviously read our givens down first. Then for number 2, we say angle DAB is congruent to angle CEB. So DAB, that's this guy right here, is congruent to CEB. That's this guy right there. You'll notice it's the angle opposite the 1, right? So that means we're going in the right order. And that is because these our two parallel lines right here are cut by this transversal, and they're alternate interior angles. So alternate interior angles are congruent. We use a little symbol there for congruent. Okay, now there's actually 2 different ways to do this proof, and you'll probably find as you're writing proofs that you can do them multiple ways. Another thing that we could do is say angle AB. So, actually, let me back up, right? So we did our givens. We didn't have any definitions. I didn't see midpoint or bisector, but our obvious but not givens are reflexive property, vertical angles, parallel line relationships. So we've done the parallel line relationships. We've done one of them. There's also another one because DC is a transversal across those same 2 parallel lines. So I could say, all right, AD. All right, so if I write that down, it would be, for number 3, it would be DA, oh, sorry, I already did DAB, sorry, ADB, triangle ADB is congruent to triangle ECB. And that is also because of alternate interior angles are congruent, right? Now, at this point, I have a side and 2 angles. So I have angle, angle, side. However, I just want to show you there's another alternate way to do this. You see that we have a vertical angle. So we have a 3rd angle that is congruent. We've got angle ABD and ABD and then EBC would also be congruent because of vertical angles. Now, I don't need to write that down because I don't need that 3rd angle. You also need to know that if you have a triangle, 2 triangles, and the angles are all congruent, that does not mean that the triangles are congruent, because angles can have 180 degrees and be small. Like an equilateral triangle can be small or it can be really big, and they'll have the exact same angles, the degrees, but they won't be congruent. So keep that in mind. Okay, so there's that vertical angle, but we're gonna pass on that for right now. So what I have now is these 2 triangles are congruent by angle, angle, side. So we can say, all right, well, we've got triangle ABD is congruent to triangle EBC because of angle, angle, side, angle, angle, side. All right, folks, I hope that that makes a little bit more clear about those relationships and how to prove triangles congruent using angle, side, angle, and angle, angle, side. If you have any questions, let your teacher know. Otherwise, see you next time.